Okay, so here's part 2. So now I want to give us a look of what happens upstairs. And when I mean upstairs, I mean in the upper atmosphere. So most of the action, frankly, of what happens in the atmosphere actually happens in the upper levels, right? So what happens down here at the surface is not the majority of what's happening in our atmosphere. Think about, like, where do you see lightning? Where does the rain start? You know, that all happens in the upper levels of the atmosphere. And weather in our neck of the woods, aka the mid-latitudes, is really largely determined by the jet stream. So this fast-flowing tunnel of air near the top of the atmosphere. So what I mean by that, again, kind of going back to this idea here. So instead of at the surface, we look at surface pressure, or like at the surface, you know, we say all these different pressures and stuff. When we look at the upper level pressure maps, instead of literal levels, like we're not looking at the 1.5 kilometer level, we're actually looking at the 850 hectopascal level, this line right here. And it turns out what we can do is actually derive that height at a constant pressure field. So this topographical analogy still works. So with this topographical analogy, we can also determine that, total sidebar, fun fact about me, is I actually have a humpback whale tattooed on my left thigh. I have a whole kind of oceanography sleeve, actually meteorology as well, but I have a whole earth science leg sleeve going on my left leg. Anyways, so when we think about our upper level charts, kind of thinking about this idea of colder air being like way more dense, right? Like cold air is super dense, and more dense, like compact. Whereas warm air is less dense. It's loosey-goosey. It's having this kind of grand old time, right? So in colder air, pressure actually decreases more quickly than in warmer air. So in this relationship here on the left-hand side, if we were to look at like a cross section, like a side view, with our colder air over here on the left, we can see that the 800 millibar level is lower than that on the right. Because on the right-hand side, the air is warmer, thus it is less dense. So the 800 millibar level is higher. Okay, so that there's like this slant that happens. So again, the colder air is more dense, it's more tightly packed. So it's, you know, lower, the upper levels are then lower, whereas our warmer air, less dense, our upper levels are then higher. And that's going to be a big thing when we talk about, say, where the jet stream is or where these upper levels are in comparison from the equator, which tends to be much warmer, to the poles, which tends to be much cooler. So in contrast to when we look at pressure or surface maps, when we're trying to look for closed regions of low or high pressure, in our upper levels, we're really just looking for patterns, more like wavy sort of patterns. And it's less common really to see these kind of closed regions of circulation. And so we try to pay attention to these troughs here, right? These kind of downward parts of the wave, and then ridges, which in this case would be this upper part of the wave, right? So this kind of, up here, this would be the ridge, this would be the trough. And this kind of pattern is super important when we're trying to do forecasting and any sort of weather analysis. So a website that we're going to use quite often is something called erth.nullschool.net, and we will look at these various levels. So for example, it's cool because it gives like this really beautiful, and not in this case because this is a screenshot, but it'll give an animated analysis of what we see. So at 850 millibars, it's only about 1.5 kilometers up, not super high, still in that boundary layer. So we see that the winds are kind of crazy. We can still see this trough here. We do still kind of see these regions of circulation. We can go up a little bit further and look at 500 millibars. Remember that 50% of our atmosphere, the mass of our atmosphere, is below this 500 millibar level. Sorry if I said 50 millibars, I meant 500 millibar level. But we can really see nicely this trough that's kind of, as we say, digging in to the southwest United States in this particular example. And if we were to go even further up, we see a similar sort of pattern, but look how much busier it is. The winds are so much greater in the upper levels. There's less friction, there's more ability for movement in the upper atmosphere. And we really look for these sort of patterns when we're trying to figure out forecasting stuff. And there's really big implications of this. There's these undulations or kind of movements in the jet stream, and these really drive weather events at the surface. When we talk about severe weather events later on in the semester, that will make a little bit more sense. We'll kind of talk about how surface low pressures are on the eastern side of upper level low patterns and how they influence each other. It's really quite fascinating. But as I said in our first week, how something over by like the Philippines can influence something over here on the west coast. It's because that penetration of that thunderstorm can really pluck the string, if you will, and kind of create this really wavy pattern in the upper levels. And so to end this lovely video lecture series here, I do just have to say that my favorite and shameless, I'm super shameless on this, one of my all-time favorite pop singers is that of Pink. I think she's great. She has a wonderful voice. It's in my personal range. And she really does a lot of great things in terms of her music. So shamelessly, absolutely love the artist Pink. So with that, thank you so much for watching, and I hope that you've had a wonderful week, and I'll see you upon my return. Thanks again for watching.